So I'm talking about today enterprise mobility, but I'm looking at it from the developer perspective. It's a level 300 talk. I am going to open Visual Studio, so if that intimidates you in any way, feel free to leave now and get an extra hour of not being in the conference or dive into one of the other sessions. So enterprise mobility is the buzzword at the moment, and I wasn't actually attending Ignite with the buzzword in mind. I worked in mobile now for 10, 11 years, working in Australia for 7 with a number of the large consumer brands, and predominantly I work in consumer mobile, and I've helped deliver a lot of the larger consumer and retail mobile applications that many of you would actually use in the Apple Store and the Android Store today. But the evolution of mobile has kind of pushed us into this enterprise play where previously we would have built enterprise applications knowing that people would have done a 9 to 5 in the office, sat in front of a desktop or a laptop, and build out these thick client-style experiences. We spent a lot of time and effort building awesome consumer experiences, and now it seems that our employees are turning around and saying, well, if you want us to be checking out emails everywhere and waking up in the middle of the night to respond to stuff on their phones, then they want the same kind of compelling enterprise experiences that we were traditionally delivering in consumer world. So my role has seen me being pushed around, sitting on the fence of consumer versus enterprise and looking at some of the plays. From an architecture as well as an engineering perspective, I get a lot of hands-on time in Xcode, in Visual Studio, looking at how we actually build applications out on the client side. But in my current role, I'm actually spanning end-to-end, looking at how we expose data, again, on both sides of the fence, consumer and enterprise, into the mobile landscape, through the edge perimeter, and then how we go for this partially connected experience, and making it optimum to the native device. I always talk about authentically native, because I'm a big believer in making something designed for the device you're using it on. I'm not against PhoneGap and Cordova, but I'm certainly not a massive advocate of those experiences either. So skipping through the slides. So today, I'm actually going to talk about enterprise mobile in the context of Office 365, Azure Active Directory, and specifically Xamarin. The reason I've gone for Xamarin for this choice is because the Xamarin stack fits nicely into the enterprise world. The majority of organizations I've actually gone in to have a good C# background. They've spent a lot of time in ASP.NET, they've got investments in WPF applications, and they kind of know their way around Visual Studio. Whereas if you go into organizations and say, let's go and recruit some Objective-C developers, we might have some Java developers hanging around that can learn Android, and then we need to bring some C# guys in to do some Windows if we're going to do a Windows experience, then it gets a little bit confusing. So Xamarin steps quite nicely into the stack. However, everything I talk about is agnostic of the development tools you're actually using. So if you want to go and do this stuff in Objective-C, in Swift, in Java, all the tooling is there. You just need to switch the development environments to get them. Then I'm going to move on to Office 365 specifically. Again, I'm using Office 365 in the context of it's a stack that a lot of companies are actually adopting now. It fits quite nicely into the Azure Active Directory and demonstrates that capability. Also plays quite nicely into that microservice architecture that we're traditionally playing with in that mobile space as well. But everything I talk about from the client side and around consuming these, the Office 365 APIs is, again, can be applied to bespoke greenfield APIs. It can be applied to the Salesforce and all the Azure Marketplace capabilities that are available. So see this as a lesson on how to consume APIs through mobile using Azure Active Directory as opposed to just using Office 365. Microsoft makes some really, really good tools that obviously consume these APIs on all the platforms, iOS, Android, and Windows. So I wouldn't go and say, let's just go and build a new email client for the sake of building a new email client. So I'm going to start on the Xamarin side. So I just wanted to get an indication of who knows a little bit about Xamarin, who knows a lot about Xamarin. Hands up if you've used Xamarin. I see one hand. Okay, that's good because a large part of my session is actually going to cover some of the basics of what Xamarin actually is. So the basis of what Xamarin is essentially it's a C# tool. It's a C# tool that allows you to actually share the majority of your code against multiple different platforms or multiple different UI implementations. It's a company that originally spawned out of Novell, when Novell was sponsoring the Mono program. If you remember Mono being the .NET runtime that runs on Linux and OS X. And then eventually it stood up as its own enterprise, and has recently gone through and got a huge amount of funding, and is pushing through quite interesting stuff in the mobile space. So I just want to quickly touch on how Xamarin works, and I'll quickly talk to you about the environment I'm using and Visual Studio, what I've got in Visual Studio before I dive into some of the specifics of the code. So the majority of us, if we've used .NET, will be familiar with this standard runtime, the standard API set that we get in .NET. The whole basis of .NET was it's kind of these building blocks. We get these core runtimes, and then when we look at specific implementations, WPF, Silverlight, Windows Phone, what we start to see is we get these more bespoke building blocks on top. What Xamarin actually enables us to do is take them core .NET capabilities and actually switch. So in the instance of iOS, we actually start to see APIs are exposed to things like the Bluetooth stack and iBeacon and core graphics and MapKit and all of the stuff that you would expect to be able to consume in Objective-C appears in C#. And it's not just an abstraction layer, it's actually a like-for-like mapping. And I've worked with a lot of Objective-C developers that I've taught C# to, and they've actually been really surprised at how Xamarin exposes this capability in that they're literally just a facade over the top of the Objective-C, and they're translating what would be a typical Objective-C method into a C# consumable method. They also uplift it, so it consumes all of the capabilities you expect in the modern CLR. So it does async await, you can use lambdas and link and all of that good stuff. So it takes the best of iOS and the best of Objective-C, and it actually makes it better because you get some of the nice language sweetness that you get from the C# perspective. If you're an F# person, all of this is also available in F# as well, so you can jump between the languages if you like. And also from both an iOS and an Android perspective, there is a whole capability around bringing existing investment from native code, so from Swift, from Objective-C, the jar files and things like that you can get from Android, binding them yourself and exposing them back into your apps. So Xamarin itself is, the basis of the Xamarin architecture is all around reusability. You certainly can stand it up and say, I want to go and build an end-to-end iPhone app just using C#. And it's great for that, and you get all the tooling around it, but you don't really get any reward. If you're going to do that, you might as well go and use Xcode, because it saves you the $2,000 on the license, and you get a whole load of debugging capability that you don't necessarily get in the Visual Studio stack. The sharing of the code is the big win, and when I talk to a lot of people, we'd normally use a golden number of around 70%. So if you look at how you'd typically construct an app, using an MVC or an MVVM style architecture, all of the M and the V and the VM, depending on which pattern you're using, is reusable. All of the integration logic is reusable. All you're really doing is you're abstracting this thinly veiled platform implementation that allows you to make these authentically native experiences. So you're actually building out a UI based on iOS, and you're building out a UI based on Android. And that way the platform actually stands up to no different to any other app built on any other technology. I must clarify that when I'm talking about Xamarin in this context, I'm talking about the Xamarin platform, the pure original Xamarin. There is a variation called Xamarin Forms, which is a cross-platform UI technology. I have got no qualms against Xamarin Forms, and there's 2 presentations tomorrow that will go in depth around Xamarin Forms and how that uses XAML as a markup language and then renders out on the various different platforms. For ease of explanation, I like to keep things simple and basic, and I can kind of demonstrate the capabilities just using the raw platform itself. So when we talk about sharing code, as the slide says, there's a couple of different methods around doing this. All of them are inherent technologies that come out of the Visual Studio team, and again, they're just latched on by the Xamarin company to build out capabilities that developers are actually familiar with. So the first one is portable class libraries. Technology that's been around for a couple of years now allows you to kind of get the common ground of the available APIs, declaring what platforms you actually want to expose to. So you'd specifically say, I want to expose to a .NET platform, to Silverlight, to a Xamarin platform, and you get to pick and choose. What you get out of the back of that is a compiled assembly that you can go and stick in something like Nougat. You can share it around, And it's really good for making up a library that you can then distribute and other people can consume. Visual Studio 2013, one of the updates introduced this concept of shared projects. This is very similar to linked class files in the oldest versions of Visual Studio, where you're writing one particular class and you're actually saying you want it referenced in both Project A and Project B. That's actually the method I will show you today. It removes that extra assembly file, extra DLL file on compilation, because it's all being rounded up into the same binary. It actually makes your application slightly faster. And good way of those sharing code actually makes it nice and easy to get dependencies into that platform-specific layer as well. Xamarin also has full NuGet support, and you'll start to see that when you download packages from the NuGet package manager, you can actually add them directly into the platform project. So you can add JSON.NET, system.net.hp, all of those stuff that you'd use on a day-to-day basis, all of the stuff that you typically use in ASP.NET and any other .NET stack. A lot of them are now straight portable into the iOS and Android projects. There are also Xamarin-specific NuGet packages that are exposed via the NuGet feed directly, and Xamarin also has its own variation of NuGet called the component store. So I'm just going to quickly show you my machine so you're familiar with the environment I'm working in before I start diving into any code. So the first thing you'll notice is I'm working in Visual Studio. So Xamarin does come in two flavors. It comes in Xamarin Studio and Visual Studio. Visual Studio, you get the access to if you pay for the business edition. It's one of the perks you get. If you don't pay for the business edition, you can work on an indie subscription, which is fairly cheap, about $25, $30 a month. And you will actually get full access to Xamarin Studio. Xamarin Studio as an IDE is good. But if you're familiar with Visual Studio, everything just works with Xamarin as it currently stands. So you can use ReSharper and everything you're familiar with. One difference you might notice with my Visual Studio is I've actually got an Apple logo in the top of the corner. I'm actually on a Mac, so I'm running Parallels in a mode called Coherent, so I can just jump between Xcode and Visual Studio. I'm using Xcode for the simulator, so I've got the iOS simulators open here, and I've also got an Android simulator here. This is the Visual Studio 2015 Android simulator that's actually deployed as part of the Visual Studio package, and that's running Android KitKat and iOS 9. So to get up and running with Xamarin and Visual Studio, it's no different to run any other application. So you can literally now go File, New Project, and you'll see under my C# directory, because I have installed the Xamarin plugins, and you'll actually see this when you install Visual Studio 2015, the Xamarin is one of the optional extras you can add in. And if you install it that way, you actually get a 30-day free trial of the business edition. You get the Android capability, and you get the iOS capability. Under iOS, you also get all the variants of iOS. So you can do things with Apple Watch, you can do things with iPad, iPhone, and with Android, you get the Android Wear implementations as well. All of these, as you would see with any other Visual Studio template, just variations on a core piece of framework. So what you'll actually see in the iOS instance is you have just a blank app, and then you kind of have some templated bits and pieces that you can pick up just to get you up to speed a little bit quicker. From a project perspective, I'm actually using the MVVM model. I'm a big fan of MVVM when it comes to mobile. It makes a lot of sense to me around the two-way binding concept of a view model talking backwards and forwards to the view. And it works really well with iOS, works really well with Android and Windows Phone, UWP, all the Windows derivatives over the last 3 years. At the moment, I've got a CANs demo, which is available on GitHub from the Xamarin site. I had an issue with my own demos earlier today, so I've just pulled down a pre-built one. And it's using just a custom MVVM implementation. MVVM Lite, MVVM Cross, Calibre, Micro, all work with Xamarin. So if you're familiar with that side of things, from Windows Phone, from Windows development, even WPF development, it all comes straight across into working on iOS and Android. So what you'll see here is the resolution. Okay, can you guys see what's on my screen? I'll take that as a yes. So what you actually see is I've got my view models, I've got a couple of helpers, and then I've got my concrete implementations on this side of iOS here and Android. when you actually look at the project, if you're familiar with the native variants of these, they look exactly the same. Android has activities, iOS has view controllers, iOS has zip files and storyboards as a way of editing. The big difference we get is working with Xamarin is we can actually do everything in one IDE instead of jumping backwards and forwards between interface builder and Xcode and things like that. So Xamarin in Visual Studio gives us a nice storyboard editor from an iOS perspective, which is very slow at loading. And then from an Android perspective, we actually get the Android's WYSIWYG editor as well. Which I'm not sure why it's so slow. So Android WYSIWYG editor, if I hadn't much around with my Visual Studio, I should have a tools menu, very, very similar to XAML editors if you're, again, a Windows developer. Even the Android source looks similar to XAML. They use an XML-based markup language. The only downside is they don't have the two-way bindings natively built into the Android markup. Storyboards are a little bit different to XAML. They're a declarative way of building out a UI in terms of a workflow and being able to click through in what they define as scenes from one page to another and building up events that way. Previously, iOS used to use an XML file called a zib, and now it's moved into the storyboard editor. But again, this is all capable. I can drag stuff on from the toolbars and everything like that. So very, very developer-friendly, developer-centric. I kind of want to keep reiterating this point because from an enterprise perspective, this is important. If you're bringing in developers that are typically WPF, Windows developers, even ASP.NET developers, all of this environment will be very, very familiar to them. I remember when I first got my job, when I first left school, and I was building an ASP.NET web forms instance, and I had an environment very similar to this, and I could drag a text box on, and I could drag a validation field on, and bind the two together. This stuff is no different, apart from you don't get all the crap that ASP.NET web forms would have generated underneath. This is actually pure code that will actually get compiled down fine, and will actually run perfectly performant on the device. In terms of performance, we also don't get necessarily any performance degradation from using Xamarin itself as well. So what Xamarin's actually doing is it's interpreting the C# code, and in the instance of iOS, it's actually compiling down to native code. So the performance is on par with iOS. There's no CLR there. It's actually very, very similar to a .NET Native you see in the UWP applications at the moment. And things like Foxtel Go, I think, are actually still used as still Xamarin apps that are running in the Apple Store today. On the Android side, it's a little bit different. It's not natively compiled. What actually happens is Xamarin sideload next to that Android Davlik runtime. They've sideloaded the mono runtimes. So they compile everything down to Java and actually just run their own implementation of a JVM, which has actually been benchmarked as faster than the Android Davlik JVM itself. So you actually get some performance uplifts from using C#. So I just want to quickly touch on Office 365. You may or may not have gone to sessions around Office 365, but where the Office 365 APIs are coming from is moving from the classic data in silos in the enterprise to opening up capabilities to developers and to users and to make it more available to do things like stick it in mobile apps or websites or customize your intranet. A long time ago, I worked on SharePoint, regrettably, because it was SharePoint 2003, and it was the worst development environment I think I've ever worked in. Things have certainly moved on a long way from there, and we've now got a nice, restful, graceful API we can consume to do things that we were never able to do when we were building web parts and workflow and all of this stuff back then. So Microsoft have certainly come around, and what they're actually now moving towards is more the graph API style model. You'll actually be more familiar with working with Facebook and Twitter. Office 365 is in this evolution phase at the moment where it sees the enterprise as a social entity and it wants to build out all of this capability. And the way it can build this capability is by publishing these APIs and allowing people to mash up their own applications and develop their own experiences. So that slide kind of talks to the same thing. So as I say, Office 365, It's exposed as RESTful. It can be all the SDKs and stuff can be consumed in anything that can consume a HTTP REST-based interface. That can be mobile devices, that can be tablet devices, that can be smart TVs. It can also be other websites. So there's no reason that what we're doing here couldn't be aggregated into an Edge API and exposed in a much cleaner way back to the mobile device if we wanted to. The specific implementation of REST that's actually going on here is OData. OData is something that Microsoft's been very passionate about for the last couple of years. They were one of the original founders, and then Netflix and a very few other people have jumped on this. If you haven't seen OData, I'll actually touch on it later on in the presentation, but it's a way of data being exposed in a particular format that is schema-based and is queryable via RESTful means. So Office 365 in its current format allows us to expose files via SharePoint APIs, mail via Outlook APIs, calendar via Outlook APIs, and user information via a combination of Outlook and the Windows Graph via Active Directory, Azure Active Directory. And it's based on this continuing evolution of the Windows Graph, which started with the Azure Active Directory implementation, moved on to Office 365, and then it's eventually going into things like Delve and a lot of the other products as well. And because it is based on the Azure Active Directory stuff, it uses the same OAuth standards that we see in all of the regular authentication providers, things like Facebook, Google, and stuff like that. So it's a convention that developers have become more accustomed to. But at the same time, it's getting all of that enterprise richness that they showed in the keynote. So every time we register something with Office 365 and Azure Active Directory, we inherit all of those event logs. We can get all of that advanced monitoring and all of that richness. The Azure AD as well, because it is a Active Directory, we can authenticate against Office 365. We want to get that token back. We can then pass it into other experiences as well. So the foundation of what I'm going to show you and show you how to build is authenticating against Active Directory, getting the token back, authenticating against Office 365. If you used to build on that experience, the next logical step you would do is say, well, we want to expose maybe some internal data out to the mobile device, or we want to go and consume something like Salesforce that can also use Azure Active Directory. Once we have the access token on the device, we can use exactly the same methods to pass, to request access back into these secondary services and get data and start building up the capability in the client a lot more rapidly. It's a standard, it's very easy to adopt and very easy to roll out both on the client and the back end. Oops, I'm clicking the wrong screen. So when we develop for Office 365, there's a couple of key steps. So I just want to kind of talk these through one by one, and each one I'll show you how to set the code up, I'll show you how the code actually executes, and then I'll move on to the next one. The steps are very, very easy and very, very logical. So hopefully you should all follow on, but if you have any questions, feel free to shout out as I'm going along. So the first thing we need to do is actually get the Visual Studio project aware of Office 365. The capability is shipped in the box with Visual Studio 2015, or if you're using an earlier version of Visual Studio 2015, you can download an extension, or you can actually reference via a NuGet project. On top of Office 365 base APIs, I'm also using a couple of extra components. The first one being the Azure Active Directory, it should be Authentication Library, not Graph Library, which is adal.net. It's been around for a while, since the inception of the Azure Active Directory. And essentially, it's the client libraries that displays that same Microsoft login box you'll see on Hotmail and Azure and Office 365. But it's now been extended as of version 3 to recognize both PCL libraries and the Xamarin frameworks. And it's actually been customized in such a way that it's able to stand up this login box and actually respond accordingly backwards and forwards. And I'll talk you through that when I look at the authentication piece. What I've also done is I've pulled down, specifically because of the way I've constructed the project, packages from NuGet, and I've pulled down the Office 365 Discovery client and Office 365 Outlook client. They're just freely available NuGet packages. You can search for them, and they're available on the Office 365 website if you're not a NuGet fan, or you can't use NuGet because of proxy restrictions and things like that. So let's take a look at actually how we get started with Office 365 and Visual Studio. So I'm just going to close all this down. So the easiest way of actually getting up and running is a nice little wizard that's been built in as a result of the Visual Studio library, the Visual Studio extension for Office 365 that is baked in as part of Visual Studio 2015. And I can actually show you how to do this in a very, very quickly manner in my Windows 8.1 project here. So what you can actually go to is Add, and you should be fairly familiar with the screen as a developer. Add reference to add extra assemblies and frameworks. Add service reference if you're a SOAP developer, and you would add WCF and SOAP commands in. And then we have this new one, which is add connected service. You may or may not have seen this before because it now does a lot of things. But one of the things you can actually do is say, hey, I have an application here. This application could be a WPF application. It could be anything. But you just want to declare the intent for it to work with Office 365. What this is actually then going to do is go and do all the hard work with registering all of the Active Directory pieces on the back end within the Azure portal. It's actually under the covers doing it all within PowerShell, pushing it up to the cloud, coming back again, and then it's going to set your project up for you. So very, very quick to do. So my Azure Active Directory is also actually my Office 365 subscription. So my domain is lewisbenge.net. Click Next. I've already authenticated because I was smart and I didn't want to type my password too many times on the stage. And then it asks me whether I want to create a new Azure Active Directory application. So what this is if you remember in the keynote, from an Active Directory perspective, we have these fine-grained controls around what our Active Directory can do. And it comes back to this standardization around OAuth. What we can do is we can register an app to say, or register an intent within our Active Directory to say we want our Active Directory to have access to a particular app. And then we get this client ID, and every time we authenticate, we go, hey, I'm this client, I want to get access, and there's a whole load of policy stuff that executes on the back end. So what this is actually doing is it's saying, well, do you want to register as an existing app within the portal, or do you want to just create a new app? So I already have a new app, I already have an app set up, but I don't want to break the demos I have, so I'm just going to create a new one. And then the next thing it'll do is it'll go off and create an app on the back end, and then it'll come back and say, what do you want that app to be able to do? And you'll have seen this experience if you're a social media user. Like Facebook login says, hey, this app wants to log in with Facebook, and it wants permission to view photos, or it wants permission to post on your wall. Office now does exactly the same thing. You have fine-grained controls for each app that removes that risk of saying, hey, let's go and get some anonymous Android app off the Play Store and go have free reign into my enterprise application, and you can do anything. You can download all my files, you can read all my contacts, you can send an email on my behalf. What you can do is say, I only want my app to be able to read, write, and drill down into very, very discrete commands against every capability that exists in that graph. So that's files, contacts, calendar appointments, and the Azure Active Directory. You literally go through, tick each one, and then once it's ticked, it's committed into the directory, that application can't do anymore. If it tries to authenticate with the token that's been issued for that client ID and it tries to do something it can't do, it will just get a 401 unauthorized exception back from the server, and the server won't let it happen. I could go through and finish this, but I want to show you how you would do it the old-fashioned way, and that's going into your Azure portal. I wasn't that smart. Now I've got to type my password in. No? Okay, it's just refreshed. So if you've got Azure Active Directory, you'll actually see your Active Directory registered in the Azure web portal. Again, my one, lewisbenge.net, is here. I can actually jump into my directory, and then you got this tab up the top here called Applications. That's exactly the same thing as what I've just done in Visual Studio. This is just a longer way round of doing it. What you'll actually see here is I've got all of my different applications. So I use DocuSign when I sign NDA agreements with Microsoft and things like that. So that's already registered, and it has some intent to read my emails and do stuff with my files. Has all the Microsoft management capabilities, and then it has my demo registered here. So if I click through, I've got Enterprise Mobile Demo. I can go in and configure. This is everything that was in that WYSIWYG editor, just presented in a slightly different way. I have that client ID, which is the ID it asked me to generate or associate with. Has the name. This is the name that appears on the login screen when you try and authenticate, again with the logo. Redirect URI. I'll come back to this in a little bit. And then down here, you have permissions. So if I look at Office 365, you see that I've ticked a whole load of permissions just because I was lazy and I didn't want to figure out which ones I wanted to demo, so I've just gone through and ticked all 15 permissions. You can be very fine-grained control on this and go through and customize it. Once you add the application, you get your client ID, you drop that in your code, and you're up and running and ready to go. So they're the two ways you can actually get Office 365 configured. Also, from an app perspective, what I have done is I've got Nougat, a couple of Nougat packages installed. They're kind of mandatory from a Xamarin perspective because you do need Xamarin to be aware of the Office 365 login screens. So as I said before, I've got this is going to take a while to load because of the internet, I think. But I've got the Azure Active Directory Authentication Library, which is the client library for the sign-in. I've got the Office Discovery Client. There we go. So I've got the Azure, the ADAL library, that's that one. I have Office 365 Discovery, and I have Office 365 Outlook. Everything else is a dependency and it's been pulled down by these packages, so it's nice and easily managed. What you'll actually see is as well, you can actually go through and just add the Nougat packages into Android, iOS, into the shared libraries, wherever you need them. Okay, so that's getting Visual Studio set up. So next is we need to authenticate. So to authenticate, like I say, this is the same flow that you would use in any kind of OAuth type handoff, handshake to get an access token. So exactly the same as Google, Twitter, Facebook. So if you're familiar with this in the consumer space, you can actually go and code this against the HTTP APIs. That way you know what's going on under the covers, you can patch any security holes and things like that. If you're not overly familiar with OAuth, because it can get a little bit tricky about the amount of times you go backwards and forwards to get the tokens, the ADAL library does a really nice job of wrapping it up. It's a Microsoft library, fully open source, so you can see the code, you can tweak it, you can patch it back in, patch fixes back in, but makes things nice and easy for us to actually implement Azure Active Directory. So where we start is we have this concept of a context. So the context, I think, is essentially a singleton. And I say I think, I haven't spent enough time with the source code to understand how they've implemented it. But I think it's a singleton because it maintains a cache. When we go backwards and forwards between various calls, we have constantly having to renew these tokens that are issued to us from Azure Active Directory because they have a short lifespan. But what you actually see in the demos is it doesn't ask you to log in each time. Obviously, if it's not asking you to log in each time, it's kept stuff in memory or it's persisted it to disk. So that's why I think it's acting as a somewhat singleton reference. So that then uses, what happens is we initiate the context and we give it what's called an authority. The authority is the domain that it wants to authenticate against. So you'll see it's actually there from a URL perspective. I'm trying to use the mouse on a PowerPoint presentation. That's not going to work. Let's try this pen. So here you've got the authority. In code, we've just got this what's called a common endpoint. So login.microsoftonline.com/common is the generic Azure Active Directory login. Actually will eventually work for Hotmail as well. So all of the stuff that's being exposed to Office 365 will work for the personal versions as well. So this is the general login if you want to authenticate against any Microsoft credential. What actually happens is once I authenticate and I'm successfully authenticated, we get what's called a tenant ID back again, and then that customizes that login authority to my domain. So it means that it knows it's me, it's my domain, and it won't keep switching backwards and forwards to the generic endpoints. So the context then goes and gets a token. And to get a token, it needs a couple of things. It needs the client ID, which is what was generated when I was in the portal or when I went through that wizard within Visual Studio. It needs a resource ID and a return URI. Also needs the authentication parameters, which I'll talk about in a sec. The return URI is an interesting one when we talk about OAuth on the client, because obviously we don't really have a concept of being in a browser. We can't ask the server to post back to us. So that's where these authentication parameters come in. So essentially, when we went through that WYSIWYG tooling to get our client ID, we would have actually defined a return URI to say, once you've completed, this is where we want you to go. Traditionally, that would be a website. In our instance, we just say anything, HTTP, localhost, hello, whatever. What the authorization parameters are doing from a platform perspective, when we're on iOS, Windows, Android, wherever, is actually constructing these web views up to look at the URIs as they're ticking over and saying, hey, this is the URI that I know is the return URL that's been served back to me. And then it captures that and then destroys the web view and then strips all the information that's been passed back and passes it back into the native application. So it does it fairly efficiently and fairly well. And you'll actually see it being executed in the code as I move through. So once we pass all that in, we get an access token back. We get our tenant ID back again. Obviously, as a result of you entering your username and password. Once we have those tokens, we can then go and proceed and actually access the APIs we want to. Again, tenant ID access token. So the code we're actually looking at is the code that's in the demo at the moment. Again, all of this is at GitHub, so you don't necessarily need to write this stuff down. You can go onto the GitHub demo, pull it down, it will start working. So I've skipped through a whole load of stuff. Actually, I've skipped through too far because the arrows are across everything. But this code semantically is exactly the same as that flowchart I was just showing you. So we get we get a context, we pass it the authority, which is the common authority to start with. We then step through it and say, are we still on the common authority? Do we know that someone's authenticated with us or not? If we are, then we go and acquire a token. We pass it a resource ID, a client ID, a return URI, and the platform parameters, which I just explained. If we know we're on a tenant, we know that someone's already previously authenticated with us, we don't necessarily have to ask for the username and password, so we can actually use this second method, which is acquire token silent, which means it goes and refreshes the token without the need to be authenticated. Then from there, we get our information back, we get our tenant ID back, which we do something with, we get our access token back, which we do something with. You'll also see down the bottom here that I'm actually using just a method to construct the authority that's being passed in. So to start with, the base parameter is common, and then once we actually get the tenant ID back here, we're actually refreshing that URI, and what you'll actually see is that URI will become logon.microsoftonline.com/. It used to be a domain name, so it should be /lewisbench.net, but it may now be coming back as a good because things have changed in the last couple of weeks. The arrows are kind of showing something a little bit interesting though, like settings is we need to store something on disk, and platform parameters. We need to understand what the platform is actually doing. And it's interesting when we talk about code reuse from a mobile perspective of, if we want to store something on disk, how do we store something on disk on iOS and Android when they have very different API methods of storing it? And they have different places to store that information. And again, platform parameters, web views are different to web activities, I think it is on Android, which is different to the web browser control on Windows Phone. So they all have these variations. So what we actually are using is essentially dependency injection and inversion of control to say, we're going to abstract the capability in interfaces and abstract classes, and we're going to let the platform inject the logic that it knows back into the shared code. That way we get this nice separation of concerns to say an Android code can do something that's Android specific, and an iOS code can do something that's iOS specific. I was a big fan of running all of this code myself, and frameworks like MVVM Lite do a really good job of allowing you to roll out DI containers and being able to build this stuff up. Other people like to take it easy and kind of make the most of what the platform offers. So what you actually find is Xamarin's actually stepped up with a concept called plugins, which does all this for you. It's another NuGet package, and what you actually get is a settings API that you can go store key value pair, and you don't really care about how it's implemented on the platform. It's all taken care of for you, and it just works. ADAL, the Azure Active Directory authentication, has the same concept. It needs to know about the platform it's executing on. It needs to know about the web container that it's going to display the page in. So the way that this is actually handled in the demo is we're actually just injecting the platform parameters, concrete implementation through a constructor argument back into the class that is sitting in the shared code. So it's exposed as an interface. We have concrete implementation in iOS and concrete implementation in Android, and just through a common constructor, they can both get passed in. From an iOS perspective, nice and easy. It's actually expecting platform parameters, and then it's expecting the activity that you're currently, the UI view controller that you're executing from. This is because it needs to know where to hand back to, and that's what the this statement's referred to. In Android, exactly the same thing. It's expecting the activity that you're calling from. Again, that's what the this is, and then it's passed in. Android needs a little bit of help, though, because of the way it actually maintains its lifecycle as an application. So we end up putting an override of onActivity result in here, which just means that when the web activity is finished and disposed of, it actually wakes the application back up and actually can strip all that data out of it. Again, it's all handled by the library. You necessarily don't care about this stuff. You just go onto the documentation, copy the code snippet in, and then you're done with, and it just works in the back end. Again, this is all the benefit of looking at this 70% reuse from a Xamarin perspective. If I was writing this stuff in iOS, I'd have to go and download each individual SDK, write it, and then I'd move across to Android Studio and do it all again in Java. If I'm writing all this stuff in C#, I write it once, it deploys on 3 platforms, and I get a whole load of reuse. So the plugin model, again, this is just to reinforce, this is was a fairly new thing. It's been around for about 6 months now from a Xamarin perspective, but it makes things very, very easy. You get this nice clean interface to work to, and plugins exist for about 60 different things now. So not just settings, you can get things like web activity, you can get notifications plugins, anything that has derivatives on each platform, you can just abstract it using this plugin model. Xamarin writes a load, but they've open source instructions to get things into the plugin store, and you can just download it. So the one we're using at the moment is settings, stores key value pair, and specific to the platform you're using. In iOS, it's storing the data in NS user defaults. In Android, it's using shared preferences. In Windows Phone Silverlight, it's using isolated storage. And in Windows Phone and UWP, it's using application data. So all of the concrete implementations are fundamentally different, but they're doing the same thing. You're giving it some data, it's writing it to a disk somewhere. So I'm just going to flick back to Visual Studio, and I'll show you all of this coming together. So again, what you'll see here is I've got my projects, and I have my shared application, I have my view models, and then I have this authentication helper. So I'll zoom this code in a little bit more so you can kind of see what's going on. I have this client ID, which is the client ID I pulled down from the Active Directory portal in the Azure Active Directory portal after I registered my app. Have my return URI. I'm just using localhost and a random GUID. Ignore the rest of it for the moment, that comes back later. I have my initial tenant authority, which I'm constructing based on the tenant authority using the Xamarin settings plugin. And then if I jump down to this get access token method, it's exactly the same code that's in the PowerPoint. So I'm going through, building up the authority. If it's common, going through, get my token back again. If it's not common, doing it silently, and then storing the tenant ID and returning the access token. So all of that gets us incredibly far in the process, and it was a lot of talking. The result is actually quite astounding for the little code you actually have to write. So in the interest of time, let's fire up the application and see what's actually going on. So if you're developing on a Windows machine, you can quite happily develop on Android in its entirety, because the Android compilers and everything run on Windows. And the Visual Studio Android emulator works absolutely fine. From an iOS perspective, you won't see the simulator because you need to compile an iOS app on a Mac. So the way I get around that, if I'm compiling in Mac in the cloud or a Mac on the network, is you can get remote desktop tools for Mac, like VNC and things like that, and you can actually get custom ones that will wrap particular applications, so you can kind of remote into that application. So that is the downside. Xamarin has just released version 4 this morning. It does fix some of them nuances, but it still doesn't give you a simulator that you can use for iOS, unfortunately. So what's actually happened is I've just hit F5 on my application as it currently stands. I've already logged in on iOS. I didn't want to go through and type my password in on stage because it is my email password. So I logged in just before the demo. So what typically would have happened is if it was a new install of this application, it would have come up and it would have come up with that classic Windows login box that you would see where it says enter your email address and password. And if you're an Office 365 user, it says, is it a work account or a personal account? And you go through, do all that, and hit sign in. It does that in this contained web view, and then I'd hit submit. And then what's actually happened, and you'll see, I'm using Xamarin, I'm deploying on iOS, but I get actually my debugger goodness from Visual Studio, which is the awesome part of this, is it's actually stepped through, and it's now got me this auth result back again. And then you can see I have my tenant ID, which is now a GUID, it's not a domain, and I have that access token. So that access token now needs to get passed into Office 365 APIs to authenticate against it. But that's good to go. We've now authenticated against an Active Directory. So we're ready to go and we can start consuming data. That step, which has taken me a couple of 30 minutes to explain to get to, and looks about 7 lines of code, if we was doing that maybe a year ago, it would have taken weeks and weeks and weeks of engineering time. Because you remember, as your Active Directory can be federated to an on-premise AD as well. Before that, we'd have had to go down some really weird, bespoke Windows authentication model to have got through, and that would have been slightly insecure, and just exposing the data would have been very, very complicated. The fact that we can now take any device, whether it's MDM managed or not, and authenticate against a corporate domain is a phenomenal step forward. So the next thing we want to do is actually start consuming enterprise data. So we want to start diving into the Office 365 APIs. The way we do this is we first have to understand where the APIs are. Microsoft being Microsoft built everything in silos. So they built Outlook.com and then they built SharePoint something and they built Delve elsewhere. So the unification of the APIs doesn't exist yet. The slide deck I'm using is slightly out of date because it has progressed. The graph concept within Microsoft is getting a little bit further, and you can now do graph.windows.net, and you can go /me/mail/me/calendar and start to build it up that way. But that's still in a very early beta phase, so in a production use, you still need to go via this route. And what this is using what they call a discovery API to understand what your app has the capability to consume, what the URI endpoints are for consumption, and some basic metadata around consuming that API. So very, very simple to do. So again, another singleton reference. You create this concept of a client up, very, very similar to just this basic HTTP client, and you say, here's my access token. So you want to go and it's an authenticated call, so you want to present your access token, which will go up to the Office 365 Discovery API, and the Discovery API will go back to Active Directory and say, what client is this for, what tenant is this for, what user is it for, because the nature of the directories, it can be fine-grained, so different users can have different controls based on application. And what will actually happen is it will figure out who you are, figure out what you can consume and where you can consume it from, and it will just literally pass you a dictionary back and say, hey, you can consume Outlook or you can consume Outlook Mail, here's the URI for it, and here's a resource ID for it. The resource ID is important because it was one of the parameters we passed in when we requested the access token. Every time we want to request a subsequent URI, we need to go back and refresh the access token to say, here's the resource we want to access, can we access it, and we get a token back again from Active Directory. So it's something that we keep access to in our code. The endpoint URI, being a RESTful URI, is just a URL. You could type it into the browser if you authenticated correctly, and you would see the JSON coming back again. And that's what the Discovery client does. It's purely for the purposes of understanding what we can consume and understanding where we can consume it from. You see this a lot in microservice development as well, in a very different format, but it's the same concept of not necessarily hard coding a URI. Instead of using a facade like the new model does, where it says graph.windows.com and aliasing it based on a common endpoint, what this is essentially doing is allowing Microsoft the free rein to say, we can go and change Outlook.com any way we like, and we can go and rename it to Live or Hotmail or Newmail and things like that, and your application doesn't necessarily get bound to those endpoints. Very, very good from a mobile perspective, because once we stick something out there in the App Store, we can't revoke it, we can't change this stuff. So using these discovery capabilities is a very, very good method from a rich client perspective. So again, the code from this perspective is very, very straightforward, very, very easy. We have a very basic discovery API, api.office.com/discovery. We go and instantiate a discovery client. You remember I just downloaded the discovery NuGet package. The discovery client is a part of that NuGet package. And then it requires this function. I'm not really sure why it was developed this way. It's a little bit weird for me. But it actually requires this function to say, it wants a function passed in that will return an access token as a string. So all I'm really doing there is I'm just calling the getAccessToken method that we just went through in Visual Studio with the new resource ID, which is this one, the api.office.com/discovery. The result of that method is a string, and because it's async, it's an async function there. That gets us the concrete implementation of the discovery client. From there, we get, like I say, it's a dictionary in its most rudimentary form, key value pairs to say, hey, here's a resource key, here's a URI, and then you can subscribe to that from there. I would jump through that, but in the interest of time, I want to go to something a little bit more interesting, which is how we actually then take the resources we're getting back and actually start consuming the data and showing what the end result looks like. So from a Azure perspective, from a response from a discovery client perspective, what we're actually getting is these raw URIs. These URIs are RESTful URIs, like I keep saying, they can be consumed in the browser, and depending on what we ask for, they will look something like this. So the Azure Active Directory Graph API, which is all of the GAL information you would typically see in Outlook, your name, your email address, and some basic metadata around you, can be consumed via this style of API, contoso.com being the name of your domain of Azure Active Directory. You can get group information back and people information in its most primitive form. If you don't use Office 365 and you're just using Azure Active Directory, you can consume this. Office 365 then build upon this to start using things like SharePoint and Exchange to expose pictures and photos back. You can then start to get people's calendar appointments, and you can use the Outlook capability to get their email back again. And again, we've now changed from graph.windows.net to outlook.office365.com. These endpoints are variable at the moment, which is the purpose of the discovery client. Once you get the endpoint know, the semantics of the URI is pure RESTful. You can go /me/messages if you're authenticated as yourself. If you're authenticated against multiple people, you can actually change /me to the user and ID that you want to get back, and you can go user ID /messages. Very, very good RESTful constructs here. And all the underlying operations are based on REST. I want to get messages, I want to delete a message. They're all using the HTTP verbs to actually manage that information. So very logical when you're constructing this stuff in code. And again, you can do all of this in the browser or via HTTP clients if you don't want to be using the SDKs. So like I say, messages, events, contacts, all the stuff you expect to see in Outlook and everything that was available via EWS when you was working with on-premise. Next, they've added SharePoint capability, so we can now get OneDrive for Business and SharePoint Online files back. And these files will then come back with all of the rights management information and all of that stuff that we see in the keynote as well, so we get that capability. And there should be other bits and pieces in there, which the slides have obviously dropped out. But as the Office 365 product evolves, everything they build into Office 365 gets exposed via the same graph capability. So Delve and the new PowerPoint functions, all that kind of stuff eventually evolve into the same manner. So how do we actually get the contacts? Well, again, very, very straightforward, easy implementation using the SDK. We're actually going to create a new instance of, sorry, I was just looking at that code there, and that code's actually wrong on the PowerPoint deck. We're going to create a new instance of a client, an Outlook client that, again, is a helper construct that come down in the NuGet packages. The three NuGet packages I installed was the Azure Active Directory one, was the discovery one, and now we're on the third phase, which is getting data, so I installed an Outlook one. So we actually have this concept of an Outlook client. As you can imagine, that's constructed with the access tokens that we've already got backwards and forwards. Also needs access to the resource URI as well, because it needs to know where to get that information from. On top of that, it then just exposes general operations. The way these SDKs are actually constructed is, I talked about OData earlier. OData being this rich syntactical RESTful method, so being able to pass things in a query string to say, I want to see people that have the first name that equals a blah, and I want to get that result, and I want to get 10 users and things like that. What these SDKs actually do is they're just programmatically generated of going through all of the available OData operations that are in that API and just exposing them back as very simplified methods and as C# objects instead of as JSON objects coming back again. They all come back as iQueryables, which means that we can also write Lambda statements against them, and then we execute them asynchronously, getting the data back without blocking any UI from the native perspective. So the code you see here is once we've constructed our client, we write a simple Lambda that says, hey, I want to go into my contacts, and I want to get all of my contacts by surname, and I want to get 100 of them, return me that data. And that's as simple as it is to dive into my Outlook address book. So all in all, the actual application takes maybe 25 lines of code to get up and running. When you add the nice complexity of building out two UIs, one in iOS, one in Android, it gets a little bit more complicated, but all in all, the demo took about, when I was writing this bespokely, it took about 6 hours to get up and running to write 2 apps that can consume an Azure Active Directory, authenticate, return my contacts, return my calendar appointments, send an email, and basically do everything the Outlook client can. So to get that far, that quickly, and building a true native experience, again, is quite a phenomenal task. So this time I'm going to run it on Android, and I'll actually talk you through what's happening. Actually, let me show you some code first. So what I've actually done is, within that authentication helper, I do all the discovery methods. I create and instantiate an Outlook client as a base method. I then wrap it to say, to expose it up to say, let's get the contacts, let's get calendar based on the particular resources that we in return. And then I've just again got some very simplified static helper methods that say, I want to get the contacts, exactly the same one that's on the PowerPoint. I want to update a contact, so I can take a contact that came back from the API, I can change the data, I can update it, I can delete it. Adds a bit of a mess because there's a bug in the code at the moment, so that's all being done just by posting JSON directly to the service as opposed to using the API. So from there, you actually see that these are then consumed in view models. So the view models look nice and clean. I want to delete a contact, so I go into my static helper and say, I want to delete a contact. That contact is bound. It's a view model, so it's bound to the UI in iOS. It's bound to the UI in Android. And because it is MVVM, it's a two-way binding. Again, all of this is the binding and the MVVM framework is custom based on the simplified demo that is being shown here, but you can use the MVVM frameworks you'll be familiar with and get exactly the same result. So at that point, you've got data available in your UI, you just have to display it on a screen. So in the iOS perspective, you'll see that if I jump into this contacts view controller here, because of the nature of iOS, and it not being a declarative UI, it's very difficult to actually add the bindings into the UI itself. So we do it in the view controller, and we treat the view controller more as a code behind file, similar to ASP.NET Web Forms. I'm in the wrong page, that's why. So what you actually see here is I'm getting that contact back, which is bound from that view model. It's being brought into this contact details view controller. Let's call it a code behind file for the zib or the storyboard. And what I'm doing is I'm actually going through looking for the properties to say, I've got a text box somewhere. Yeah, I've got a text box email, and I want to set the text property to the email address on the view model. It's as simple as that from an iOS perspective to bind to the iOS. It uses iNotify property change to subscribe to the property that's being bound. So if I change it, that information gets back to the view model. It's exactly the same as WPF, exactly the same as Windows Phone. So if you've worked in this space, moving to Xamarin shouldn't be complicated at all. So if I actually then run this, I'll quickly show you what the application is actually doing. That would help if I'm on that emulator. This is always a nervous bit about deploying to what's technically a remote machine, because you have these minutes of silence where it's trying to open up ports and stuff. Here we go, it's installing, should be deploying soon.
Is it fairly simple to control which version of Android it should be developing for?
Yep, so it's as simple as going into your Visual Studio project settings. So I can show you that in a sec. This one's actually chucked me out. It's for some reason, I've lost that tenant ID. So what I can actually do now is show you that process from the beginning. So I can log in. And if it puts my password up on the screen, I'm not going to log in. I'm hoping it's in presentation mode. I'm more concerned with the fact it's being recorded and my password goes on the internet. So you'll see this experience is exactly the same as the same experience you'd see logging into Skype, logging into the Azure portal and things like that. It's an iframe, essentially. It's just a web content. Yeah, I'm not going to type my password in. But you can't copy and paste, unfortunately. And I'm not on dual screen, so let me see if it's still open on the iOS simulator. Yeah, so this one's already authenticated. So you'll see the experience looks different on iOS and Android. This is why I made that point at the beginning, authentically native, I call it. And this looks like an iOS app. If I scroll down, you'll see I have a UI tab bar, which means my tabs are on the bottom. That's what iOS users expect tabs to be, and it looks like an iPhone application. If I loaded up my Android app, which I can't at the moment, but you'll see that under the material design guidelines within Android that Google produced, tabs are at the top. This plus button here on iOS is part of the app bar. On Android, it floats around. It's fundamentally different around how it looks and how it feels. And this is the benefit you get with using these platform-style abstractions to say, I'll share as much code as I can logically, because the flow and the navigation is all going to be the same. But when it comes to building the experience, it will look different. And this has a productivity gain, because when you think about giving this to employees from an enterprise perspective, if you say, I'm going to build you something on an iPhone, but it's going to look like an Android app, they're going to have to learn how to interpret that interface differently, so it's actually going to be detrimental to them. So building things natively is actually quite an important aspect. So what we've actually got here is all of this in real time is actually now hitting my Office 365 instance. So I can actually say, I want to go down, go into my calendar. You'll see it's refreshing because all of this is pulling from the server real time. I want to go and I want to create a meeting for 5 minutes. And I want to create it for today for 7:30. And I hit schedule. That's going up to the cloud. And then I can actually go into my calendar here and you'll just see I've got a 5-minute meeting that's just appeared from the app. So real-time interaction via the Office 365 cloud, Office 365 APIs. And that's pretty much all I've got to show you. So what I was trying to get across in the presentation and what I'm hoping that you've walked away with is when we talk about enterprise mobile, is actually looking at these really, really basic concepts of let's go and authenticate with something like the Azure AD. And this necessarily isn't exclusive to Microsoft. There are a couple of federated identity providers, Novell have one and things like that put stuff in the cloud, but they have these rich client API implementations. They don't necessarily all have Xamarin implementations, but that's not a prohibitor. Once we've got these tokens back again, be it an OAuth token, a JWT, a SAML token, we can then build edge APIs that expose information, or we can consume the Office 365 APIs and bring enterprise data down again. It's the fact that we're using Xamarin means that we can build these experiences that people are familiar with. It's easy to consume, and people are going to be happy. They can bring their own devices in, and when you're dealing with an enterprise that have got variations of different phones, like I've worked in organizations that sometimes issue Windows, some issue iPhone, some issue Samsung, it means that people are comfortable, they can do what they do, and they can do it more productively. So I'm hoping this has been beneficial to you. Like I say, this is my job. I do this stuff in and out, and I've done it for 10 years. So I'm here for the next 2 days, and I'm happy to talk to anyone that's got specific questions around how to build a mobile device looking at enterprise capability, how to expose enterprise capability out using Azure or using other products if you want to talk about other products. But for now, I feel like I've talked enough, so I'm going to let you all go. If you have any questions, feel free to raise them. If not, I'll see you at the party tomorrow evening. Thank you.
Email form.
Sorry?
Emails.
Emails? I've got nothing. There we go. I've completed my slide deck for you. Any questions?
Yeah, is your sample available online?
So that sample isn't my sample. I stole it from an evangelist in Xamarin called James Montenegro. So if you go to the Xamarin blog, which is blog.xamarin.com, you'll see there's an Office 365 thing there, and you'll see all the source code and everything linked. If not, if you follow me on Twitter, @LewisBenge, I'll tweet about it in the next day or two and link you to it there. I just remembered your other question as well about Android versions. I'll quickly flick back to Visual Studio. So the question earlier was, how do you define what Android version you are and what SDK you are? So first of all, you have to have the Android SDK installed. So if you want to target an earlier version like Ice Cream Sandwich or something like that, you have to have Android version 18 SDK installed. But from an Android perspective, it's as simple as going into your Visual Studio project. I can't remember where it is now. Here we go, Android. Application, compile using level 21. Your minimum target is 15. Your target Android version is 21. So typically that would be done in a different fashion within Android Studio or Eclipse, but things like the compile version and even the manifest declaration, Xamarin actually remove all the XML declarations that you typically do from an Android perspective, and they just make it in a more easier consumable format. So yeah, you can just go through ticket and stuff like that. But yeah, very, very simple at doing that. iOS is exactly the same. If I go into iOS projects, you actually see that I can go and I can declare my bundle name, I can declare my provisioning profile, I can target particular what version, I can declare that it's using Apple Watch and all that kind of stuff, exactly the same as you'd expect in Xcode, it's all been bought from Visual Studio. This morning Xamarin released and Xamarin Platform version 4 as well, adds a lot more capability into Visual Studio, which because it was released 8 hours before my demo, I didn't have a chance to upgrade it, but I'd certainly recommend you having a look at that stuff as well.
Is it a valid sample to UWP to take advantage of single sign-on when the Windows 10 devices, even in Azure AD?
Yeah, so I've deliberately not spoken about Windows because Andrew Coates is running a Windows session tomorrow, so he's running a Windows 10 UWP Office 365 session. But what I do have here is I actually have a Windows 8.1 library. It's just consuming the same view models. So if I actually jump into my code behind here, you'll see that I've got my authentication helper doing the platform injection. I'm defining the data context as the context view model. It's using exactly the same. Like I say, things like MVVM Lite and stuff like that will all come through. The libraries are just NuGet packages, so it will identify which packages are the right ones. So yes, is the simple answer to your question. Any other questions? No? Thank you for staying around, guys. I know it's been a long day. I hope you enjoyed it.